is another problem that involves a 3D figure, so we have to make sure that we can visualize this in 3 dimensions. The other thing about this problem is that, so we have a sphere that's placed inside this cone, okay, and it's a 60-degree cone, so it means that this top angle is 60 degrees. So this is essentially an equilateral triangle, and we want to know how far the tip is from the bottom. The tip of the cone is from the bottom of that sphere. So first of all, we need to make sure that we do this in 2 dimensions. So we have to imagine slicing through this and getting this equilateral triangle with a circle in it. Now, one of the things that we have to do is make sure we generate a right angle triangle. And one thing that people like to do this is to draw a line like this through here and make the triangle like that. And the problem with this is that if we actually take a close look at this, here's a right angle triangle. That is definitely a 30-60 triangle. The problem is we don't know any lengths in this diagram. The distance from the center here to the edge, there's that little gap in there. Okay, there's a little gap right in there that we can't account for. Okay, we don't know the distance from here to here. Okay, we know the radius is 10. And again, we don't know the distance along here. Okay, so this is a problem if we make our triangle like that. So the key to the problem like this is, and most problems like this, is we want to use the fact that there's a center of my circle, and this line that goes to the line that's just touching that circle, that's going to make a 90-degree angle. And then this then generates our right angle triangle here. So there's our right angle triangle. We know that this length here is 10. We know that this length here is 10 because that's a radius. And we have our 30 degrees in here. So if we really know our 30-60 triangle, we know that this length here is a hypotenuse. This is the short side of the right angle triangle. And so this should be double, so that x should be 10. Okay, so I'm going to redraw this. Okay, so this short length is 10. I know that the length from here to here is also 10, and we're trying to solve for this length x from here to here. That goes to the tip of that's going to go to the tip of the cone. So if I compare this to my known 30-60 triangle, it's 1, 2, root 3. Okay, and again, I make sure that my long side is my root 3 side. There's my long side. I can see that setting up this ratio of my adjacent to 60 degrees. Okay, so this is my 60 degree in here. My adjacent to 60 degrees over 10 plus x is equal to the adjacent to the 60 degrees in green, 1 over 2. And then solving this algebraically, we can solve this as 20 equals 10 plus x, and then we get our x is equal to 10 that way. Okay, and again, if we're really familiar with our 30-60 triangle, we would know that that length is double the length of the hypotenuse, and that length there represents the hypotenuse length. So in these problems, we typically want to involve the center of the circle and the radius. If we don't want to draw these types of triangles where there's missing bits of length. Okay, it's because that becomes misleading, and that looks like it could work, but it does not work. So when we're dealing with these problems, with these trig problems, we want to make sure we have these skills that allow us to solve these problems. So one of the main skills that we're going to use is the Pythagorean Theorem, finding the third side of the right triangle, whether it's the long side, the hypotenuse, or one of the shorter sides. Another skill we need is to be able to find an angle from known sides, okay, and finding a ratio from the angle only. So from the 2 known sides, we use the inverse ratios, okay, inverse sine, inverse cos, inverse tan. So if I give this inverse sine or arc sine the ratio, I get an angle. And the reverse is true here. If we have the angle, we put it into sine function, and we're going to get the ratio. And essentially it's going to look like this. Okay, if I have the ratio, I'm going to go in this direction. I'm going to use my calculator. Again, we need to translate ratio to angle. This is the description of the shape using a ratio. This is a description of the shape using an angle. And we use a calculator to figure that out. And from ratio to angle, we're going to go in this direction. We're using the blue. We're going to use our inverse sine, inverse cos, inverse tan. If I start with the angle and I want to know the ratio, I'm going to use sine theta is going to give me a ratio, cos theta is going to give me a ratio, tan theta is going to give me a ratio. And unless it's a special angle, we use our calculator. If we have special angle ratios, then we don't need a calculator. We can find the exact values. The other thing is we want to be able to solve the right triangles with an angle and a side. Okay, if we have an angle and a side, we should be able to solve this right triangle. And we should also be able to solve a right triangle when we have two sides of the right triangle, because we know the shape and size of it. Okay, and that solving the right triangles involves finding the shape and size.